Okay, so today we're kind of expanding on what we did with mean, median, mode, range, and standard deviation. So today we're going to talk about two unique situations. The first one is data transformations using addition. So let's look at what that means. It says when a number k is added to each value. So think about this. When a number, like a certain number, k just represents a number. So when some number is added to every single value in the data set. That's what this is talking about. Then what we can conclude is, first of all, the measures of center, which are the mean, the median, the mode, okay? The measures of center can be found by adding that k, the number. So adding that number to the original mean, median, and mode, all right? We'll look at an example for this in just a second. Okay? The measures of variation, which are the range and the standard deviation, are the same. They do not change, okay? The new measures of variation don't change. Even if you add, let's say, 20 to every single number in the data set, the range and the standard deviation won't change. So we're going to refer back to this. Let's look at our other scenario real quick. So the other scenario is transformations using multiplication. So that was addition. This is multiplication. So this is when each value, every single value in the data set, so every number in your set, is multiplied by a number k, okay? And we're assuming k, the number, is a number that's not 0. It's got to be a positive number greater than 0. So when each value is multiplied by the same number, then here's what's happened. The measures of center, your mean, median, mode, can be found by multiplying that same number to the original mean, median, and mode. So basically, you take the mean times k to get the new mean, the median times k to get the new median, and the mode times k. K is just the number you're multiplying by to get the new mode. And then the measures of variation can be found also by multiplying k to the original measures of variation. So you'll take your range times k and get your new range. And you'll take your standard deviation times k to get your new standard deviation. Let's go ahead and write that up there with addition also. So let's write a recap on addition just to help us out. So it said that your mean, you would add k to it to get your new mean. Sorry, I'm getting messy there. Hold on. Your median, you would add k to it to get your new median. And your mode, you would add k to it to get your new mode. And then it says, okay, and then it says that the range, and I'm going to put SD for standard deviation, stay the same. They don't change when you're adding a value to all the numbers, but when you're multiplying, they do change. So that's our rules we're going to refer back to. Let's look at some example problems. So example 1 says, 2 reality cooking shows select 12 contestants each. The ages of the contestants are shown in the tables. So we have show A and show B. First, it wants to find the range of the ages for show A. So for show A, remember range is max minus the min. All right, so our oldest person on show A is 31, and our youngest person is 19. So we're going to do 31 minus 19, and we get 12. Let's do the same for show B. Go ahead and find the range for show B. Okay, so the range for show B, the oldest person is 48 minus the youngest person is 19. The range is 27. So it says compare your results. All right, well, if the range on show A is 12 and the range on show B is 27, that means that the ages of the contestants, because that's what we're talking about, ages of contestants are much closer together, like they're closer to the same age, in show A than in show B. And that's because the range is smaller. That's how I know they're closer in age. Okay, let's look what it says here. It says, after the first week, the 25-year-old is voted off show A, and the 48-year-old is voted off show B. How does this affect the range of the ages of the remaining contestants? Well, if you look at show A, like if you look right here, show A, the range was found by taking 31 minus 19. So if you take out a 25-year-old, you did not change the oldest or the youngest person on show A. So it doesn't affect show A because the 25-year-old is not the max or the min. All right, let's look at show B. If you take the 48-year-old off, that's changing the max. So if you took the 48-year-old off, the new max would be 32. And so on show B, your new range would be 32 minus 19. All right, and that would be your new range is 13. And the reason it changed is because the max changed. By taking out the 48-year-old, we changed the maximum. Okay, let's look at the second page. We have another page to look at. So it wants us to find the standard deviation for show A and find the standard deviation for show B. So I'm going to have you put all the numbers for show A in list 1 and all the numbers for show B in list 2. And we have instructions on yesterday's foldable of how to do that. So go ahead, I'm going to pause that and let's put our numbers in our calculator now. Okay, so I have all my numbers in show A is in list 1 and show B is in list 2. So now remember how we find the standard deviation is we press stat, we go over to calc, go over to the right calc, and it should be on one variable statistics, hit enter, and list 1 is show A, so we're going to go down to calculate and hit enter. And the standard deviation is right here, it's the sigma x, so it's 4.20. So we're going to just pause and write that down. So standard deviation equals 4.2. And let's go ahead and find it for show B, and then we'll interpret our results. So for show B, to get out of here, I'm going to do this blue quit. It's above mode right here, so I'm going to hit second and then mode. That just quits me out of anything. So let's go back to our list, stat, okay, hit enter on edit. So now list 2 is show B. So I want to do the same thing but with list 2. So how I do that is I do stat, over to calc. I'm still doing one variable stats. Now here's the difference right here. On list, it says list 1. That's going to calculate it again with list 1, which is show A. We want to change this to L2. So how we do that is right down here, it says L2. You see it's in blue. So to get that to say L2, we hit second and then the 2. And see how it changed it to L2? And that is going to say, hey, do this same thing except use the numbers in list 2. So it just switches it. Go down to calculate and hit enter. And the standard deviation of list 2 is 7.47. All right, so standard deviation is 7.47. So what the standard deviation means on show A is standard deviation, if you look at your foldable from yesterday, talks about the typical number. In this case, it's a typical age because we're talking about ages. It's the typical age of a contestant on show A. That's just kind of telling about what we're doing. We already knew there were ages of contestants on show A. So the typical age differs, meaning up or down, from the mean by approximately, those little squiggly equals mean approximately, 4.2 years. So that means most contestants are either within 4.2 years above or below the mean. So most of them, not all of them, most of them. So let's try writing this one over here. So see if you can select the correct statement. Use the same type of format I have right here to do this one. Okay, so I use the same format, meaning I use the same wording saying the typical age of a contestant on show B differs from the mean by about 7.47 years. So it means on show B, most contestants are within the range of 7.5 years, either below or above the mean. They're in that kind of range of numbers. So compare the standard deviations for show A and show B. So I'm going to use the symbol for standard deviation. So the standard deviation for show B is bigger. I'm going to say greater. That's a good word. So since it's bigger or greater, it means the ages are more spread out on show B. All right. So, example 2, find the mean, median, mode, range, and standard deviation. I'm going to go ahead and have you do that now. Okay, so I found my mean, median, and mode, just like we had learned yesterday, and I used my calculator to find my range and my standard deviation. So all of my numbers are there. So now, that was from yesterday. What's new today are these questions down here. It says, find the mean, median, mode, range, and standard deviation. This is the key here. When each hourly wage increases by 50 cents. That means we're adding 50 cents to every number in the data set. So we're adding a number to all of the data. So what that is back on that first page, it's data transformations using addition. When a number is added to each value, then you take the mean and you add that number to get the new mean, the median, add the number to get the new median, the mode, add the number to get the new mode, and the range and the standard deviation stay the same. So what we're going to do is we're going to go ahead and we're going to, remember the number we're adding is 50 cents. So we're going to take the mean, which was 9.65, and we're going to add 50 cents. So the new mean is going to be $10.15. Okay, so the median is going to be where we take 8.7 and add 50 cents because we're adding 50 cents to everything, and we get 9.2. The mode is 8.25. We're going to add 50 cents. 8.25 plus 50 cents is 8.75. That's the new mode. Okay, and the range in the standard deviation when you're adding by the same number stay the same. So the range is still going to be 8.25 or $8.25. And the standard deviation is still going to be $2.61 or $2.61.